Alright, so this is example 1, part B, that I skipped during class, or in the class video. So to talk through what's going on here, so it says the manufacturer of a certain brand of aluminum foil claims that the amount of foil on each roll follows a normal distribution with a mean of 250 square feet and a standard deviation of 2 square feet. So we want to know the probability that a random sample of 10 rolls has a mean area of less than 248.5 square feet. So what makes this a sampling distribution problem is that I'm talking about a random sample, and I'm talking about the mean for that sample, the mean area for that sample. Because I'm not talking about an individual roll of foil, I can't just use the original mean and standard deviation and really even shape. I have to think about what is this sampling distribution. If I were to take many samples of 10 rolls, what would be kind of the typical mean for each of those groups of 10 rolls, and that will kind of help me figure out how out of the ordinary is this number compared to all of those. So that's kind of the idea, and that's why we have to do a sampling distribution. So I'm going to follow the same 4 steps that I did with proportions, that I did with any other sampling distribution problem. I'm going to first check my assumptions / conditions. So my first one being that I have a random or representative sample that is given. So I'm just going to say given a random sample of 10 rolls of foil. Our second condition or assumption has to do with independence. So if I'm picking these rolls of foil without replacement, I want to make sure that my probabilities and my numbers aren't changing too much. So my sample size of 10, I need to assume is less than 10% of all rolls of foil in the world. So again, probably safe to assume. So I'm going to say that, and we'll move on to the next one. So then my last condition has to do with normality. How do I know that my sampling distribution is going to look roughly normal? And that can come from 2 different options. The first option is, was I told that the population distribution for single rolls of foil is roughly normal? And in this case, that I was. So that would actually be enough, and I can just say, given that the population distribution was roughly normal, so I'm good to go. I know that any sampling distribution that comes from that population has to also be roughly normal, no matter what the sample size is. If I was not told that, then I would need to look at sample size and see if my sample size is bigger than about 30. This one is not, so it's a good thing we were told that our population was normal, otherwise we'd be stuck. So that's step 1. So now we can move on to step 2, which is to calculate the mean and standard deviation for this sampling distribution of 10 rolls of foil. So I'm going to start with my mean. Our formula for mean says that the mean of the means is the mean. In other words, the mean of all of these sample means of all of these samples of 10 rolls should be the same as the mean of the original distribution, which is 250 square feet. And my standard deviation formula, standard deviation of the sample means for our sampling distribution, is we take the original standard deviation that we were given for the population, and we divide it by square root of n, which is our sample size. So my original standard deviation was 2, and we're going to divide that by square root of 10, which was our sample size. And once I put that into my calculator, that comes out to 0.632. Again, we can use the entire kind of formula in a minute in my z-score so as to not round. Otherwise, just make sure you're rounding to at least 3-ish decimal places. All right, so that is step 2. So next we're going to move on to step 3, which is to kind of draw and shade and use our normal model to find our probability that we are looking for. So let's go ahead and do that. I'm going to start by drawing my lovely normal model as best I can and labeling it with my mean. If we wanted to, we could go ahead and add and subtract that standard deviation for this sampling distribution, that 0.632. We could add that 3 times on either side, but I won't do that. I'm just going to go ahead and find a z-score. So again, sometimes it can be helpful to write out a little probability notation. In this case, I want my sample mean. I want the probability that my sample mean for that sample of 10 rolls to be less than 248.5. So then that 248.5 becomes my z-score. So I'm going to go ahead and find my z-score. My observed value is 248.5, that looks like a Z, minus the mean that we found was 250, divided by my standard deviation of 0.632, which gives me negative 2.37 is my Z-score. So negative 2 and maybe a little bit more standard deviations below the mean is where this value of 248.5 ends up. And then we want less than that, so I'm shading less than. And now I can look at my Z-table to figure out that probability of our Z-score being less than negative 2.37, which is 0.0089. And remember, our Z-table always gives us a less than probability, but that is actually what we want in this case. And it does seem to kind of match with the area that I've shaded, so we know we're good. So that is step 3. We have now found the probability, and then our final step is to interpret that probability. So when I do that, I can kind of take the question that I was asked if I need to, and just reword that as an answer. So I could say something like the probability that a random sample of 10 rolls of foil has a mean area less than 248.5 square feet is 0.0089, something like that. We can kind of rearrange the words. There's different ways we can say that, but that's in a gist what we're saying. And there we have it. So I kind of rearranged the words, but there's about a 0.89% chance, less than 1% chance, that a random sample of 10 rolls would have a mean area less than 248.5 square feet. So crazy, crazy unlikely for that to happen just by chance. So if a company or whatever, if a random consumer were to have 10 rolls whose mean area is less than 248.5 square feet, then they should be shocked. They would be surprised. They would be confused. Why did I happen to get this? Is the manufacturer being truthful about this 250 square feet? Very important questions. You know, foil is important. Anyways, that is it for this example. Let me know if you have any questions.